We get asked all the time, how do we avoid the 80-20 rule, where 20% of the work seems to take up 80% of the time when you're writing code? And that usually comes down to chasing down bugs and dragging out a project to a schedule, exceeding the timeline and budget. How do we go about avoiding that? And I'd say one of the biggest keys in the way that we do that is by implementing automated unit tests throughout the development. So the end result is you get code that's well thought out, it's reliable, and it remains stable as you build more and more functionality on top of the code you just wrote. So today we wanted to take a little bit of time to talk about the importance of unit tests in your product development and the total cost of ownership. So I have Dave Abramson here, our senior systems architect, to discuss that a little bit with us. So what are unit tests?
Unit tests are pieces of code that exercise other small isolated bits of code in your system.
Okay, and why are they important?
Well, like you said, they increase the reliability of your code. They give you a level of comfort and protect against change. I don't know, a lot of people may have heard the term whack-a-mole.
Mm-hmm.
When you change one piece of the code here, then another problem over here happens. If you don't have automated unit tests, it could be days or weeks before that other problem is detected. Whereas if you have unit tests that's constantly testing this code over here, a change over here, you run all the unit tests, now you see a failing test over here.
For those that aren't super familiar with it, like how often are unit tests run or how are they set up?
Unit tests should be run by the developer at least every time before they check code into the whatever repository you're using. At the very least, preferably they're running the unit tests as they're writing code. So they'll be writing a test that fails and then writing the code that makes the test pass.
Is that also called like test-driven development?
Yes, that's the basics of test-driven development.
Okay, so if we've heard that term, that's a lot of what that's referring to.
Mm-hmm.
Okay. Are unit tests required?
Not all the time, but they should be all the time, in my opinion. If you're on my project, they are. But I know that, I think that any project that adheres to SIL level 2 or
like an
any
industrial project, industrial work,
or any class 2 or 3 medical device, software safety class B or C is required to have unit tests.
Okay, so that's something that regulatory bodies are looking for when you submit a package to be marketed.
Yes.
Okay. How do you implement a good unit test?
Well, it should be small and it should test an isolated piece of code. And what I mean by isolated is that you're not going in at the highest level of code and pulling in all these other different dependencies to run the test, because that just creates more points of failure.
Okay.
What you're trying to do is isolate code and test it one thing.
Like one function?
Like, it could be one function, or it could just be one logical unit of work.
So
that may take a few function calls.
Give me an example. Like parsing in a message, or like is it more or less granular than that?
Sure. So let's take the example maybe of receiving a message over Ethernet.
Okay. Ethernet.
And then parsing that message out.
Where would you unit test at? What level?
Okay, so you would want to unit test the parsing for sure. You may or may not need to test something at the Ethernet level. The thing is, with unit testing, you want to eliminate dependencies.
Okay.
So you're certainly not going to test at receiving the Ethernet and then going all the way down to parse, right? What you're going to do is have a buffer that you essentially assume was received over the socket.
And then test it from
and
there.
then test that in your parsing logic.
All right. So if building a buffer was something that all should be tested, that should be done separately.
Right.
Got it. Okay. So breaking up into small testable parts where each thing, if one thing fails, you know what failed and it's easy to go find and fix.
Yes.
Is kind of the idea.
Yes.
Makes sense.
Yes. I also think that a good unit test has a clear name. And in the name It should say what's being tested,
Mm-hmm.
the scenario under what it's, or the conditions under which it's being tested, and the expected result. This way, when you're looking at test explorers or lists of results of tests, you can easily filter them. You can easily search them into groups of tests.
Great tip. Okay. How do you think unit testing affects the overall project schedule budget?
Well, I think you probably end up with about 25 to 30% more time in development. That's not to say it takes 30% more time to develop the unit tests, because you can actually reduce your time developing the product code if you're writing good unit tests as you go.
Because you're thinking about what the function needs to do when you write the unit test, so the thought part's already kind of done. So it's a different approach.
That's right.
Okay. Is it safe to say then that that's how we really help escape the whack-a-mole situation at the end, where we're investing that extra 25% up front, but we're not doing 25% bug fixing at the end?
Yeah, whack-a-mole can take a lot more than 25%.
Not to mention you get better quality code at the end too, right? Absolutely.
Better quality. It's more reusable units of code, more loosely coupled, and it's testable. I mean, the code is testable. If you're writing unit tests as you write code, you're naturally going to write code that can be tested.
It's just kind of
right. Yeah. So if you're using unit tests, gone are the days of writing your code, starting up the whole system, and stimulating it manually in such a way that you hit the code you just wrote, and then set your debugger breakpoints. I mean, you'll still do a little bit of that, but largely you just write your test, you write your code, you run the test, it passes, you move on.
So then you don't have to think about it anymore.
And you don't have to think about it anymore until the test fails.
So I'm thinking about, too, what you're saying. It also sounds like it probably enforces better coding habits across your team, too.
Absolutely.
Yeah. So you get those added advantages of everybody's kind of writing things in a similar way, and it makes everybody's code work together better.
Yes, and then you can run tests overnight as part of automated builds, and you can stop problems early before they become bigger problems.
Is it safe to say, too, when we're implementing unit tests, you end up spending the time there, but then that ad hoc and regression testing, then you're also getting a savings there, not to mention the whack-a-mole at the end.
Oh, huge savings.
But your integration test and your system level test is probably simpler, too.
Absolutely, and the testing is repeatable.
Yeah, and it's done for you automatically.
It's done for you, yeah. If you're doing it manually, just ad hoc, you might be doing different things.
It's hard for a human to act like a machine. And be consistent in the way that things are tested time and time again.
Right, and then you might do something differently and something passes when it shouldn't have. And the other nice thing about unit is if you find a bug, you can write a unit test that exposes that bug.
And you won't re-incur it later.
And then you just change the code to make that test pass. And then as long as that test continues to pass,
you have
the bug is gone.
Great. So it helps to head off. It sounds like there's a lot of hidden benefits that if you're implementing this, it really has, it's a virtuous cycle kind of the whole way across the code.
Yeah. Okay. And they're only hidden if you're not doing it. If you're not unit testing, that's the only time they're hidden. Once you start doing unit testing, they become painfully obvious, those benefits. All the old ways you were doing things, you'll kick yourself.
So what does someone need to know when they're starting a project about how they actually set this up and start doing it?
Well, they'll need to decide what testing framework they're going to use. And there's a lot of testing frameworks out there. Any language you're writing in these days has a testing framework.
What does it cost?
It shouldn't cost anything. You can pay if you want, but I've never paid and they're fine.
There's a lot. So there's a lot of tool chains, a lot of test frameworks that are out there that are freely available.
A lot of test frameworks freely available, and tool chains, which is something different.
Thank you. So once you've determined what tool chain you use by doing a little maybe Googling, a little research, what are your next steps? How do you go about mocking up and stubbing out and setting it up?
Oh, that's actually something I forgot. In unit testing, there's a concept of mocking or stubbing objects, which is basically setting up code that allows the code you're testing to run without a concrete dependency.
Okay.
So say, for instance, go back to that parsing.
Yeah, put this in terms even.
Right, so say I'm inputting a stream into my parse function, right? Typically, maybe that's like some kind of socket stream.
Okay.
Into the parsing function. I could change that and instead use a in-memory stream to pass into the parsing function. So
it's a buffer that you're controlling as opposed to the actual coming in.
And so you're dependent. When you're unit testing, you're going to end up writing code that depends on interfaces, not concrete objects.
Which is also kind of another good concept of
well, that's how you end up with that's how you end up with the loosely coupled code, more reusable, stuff like that.
So you touched on naming conventions. Is there any more you could kind of expound upon and to help folks out tactically when they're actually setting up the tests?
Can I go back to mocking and stubbing?
Sure.
So there's mocking and stubbing frameworks that you can get that are also free.
All right.
So if you're using G-Test.
Is that a good example?
Yeah, a lot of people will use G-Test for C and C++.
Which is a lot of the work we do is in C and C++.
And it's freely available. It runs on Windows. It runs on Linux. You can run it on embedded platforms. We've run it on a STM.
So even microprocessors, we can run.
We run unit tests on micros.
Which is something that I think a lot of people don't think that you can do. But it's so in that.
You can absolutely do it.
And
it doesn't even have to be fancy. It can just be, I mean, worst case, if you don't have an OS or you're just bare metal or whatever, you just have a compile switch or a different way of building it that instead of initializes all your hardware and goes into your executive loop, just calls a bunch of tests and puts some stuff and writes to the output. So you get feedback that way. There's really no reason not to test. But the mocking framework, G-Test has Gmock, which allows you to create basically objects that you make when your code that you're testing is going to call one of those interfaces. You can make it just do something like return 5 if that's what you need it to do.
Okay.
Something like that.
So I love that we're getting down into the weeds and a little bit of the tactics of this. This is really good for engineers that maybe have dipped a toe in or they think they're ready to get into it. I see you brought along a reference here. Is this something you'd recommend?
Yeah, I would recommend this book. It's The Art of Unit Testing by Roy. I'm not even going to try his last. Well, Osharov. I'm not really sure. Anyway, it's a really good book. And
non-paid endorsement, but this is actually something that we use around here.
Yes, I think every intern that comes in here says, "How do I write unit tests?" And I just kind of say, "Read this and ask me questions."
Got it. So, if we have any other questions about unit tests, you can see we got kind of technical on this, but we're happy to answer any other questions that might come up. Also, we'll put a link to the book in the comments. If you're interested in it, it's a great reference, and it's actually, as far as programming books go, it looks a little heavy, but it's actually not too bad. So I think this is one that we can wholeheartedly recommend. So,
and it also talks about, there's a good chapter in here about changing your company culture.
So there's some actual application about how people can use it.
Yeah, how if you're in a company or that doesn't do unit testing,
how you begin to introduce the idea.
Yes. Because you'll find resistance at first.
So earlier, Dave, you mentioned writing the unit test while you write the code. What's the advantage to doing that as opposed to writing the unit test after you've written the code?
Well, if you write them after you've written the code, it's likely that you haven't set up your code to work off of interfaces. And all your dependencies are going to be concrete. classes are going to depend on other classes. You're going to have to initialize a bunch of code just to test one little piece.
That's when the time to do it could really stack up.
Yeah,
that's when you start losing the advantages.
Right, you lose a lot of the advantages if you wait until after the code's been written, because you won't be writing code that's testable, because you're not in that frame. You're not in that frame of mind.
Right. Yeah. So if you're ever faced with the prospect of having to go back, maybe for some regulatory reason, and writing it, it's something that you can do, but it's something that you should try to avoid at all costs if you're doing fresh development.
Yes.
Great. So. Thank you all very much for tuning in. Thank you, Dave, very much for getting very tactical with us and also sharing a little bit about unit testing. We hope this is useful. And again, if there's anything else that we can share with you, please put it in the comments and we'll respond. And we're happy to create another video like this one. So thanks very much.
If you found this video to be helpful and would like to learn more, or if you'd like to learn about another specific software development related topic, let us know in the comments below or send us a message at info@psi-software.com.